This problem involves a 2D integer array coordinates and an integer k. Each element in coordinates represents a point's coordinates as xi, y, and the distance between two points is calculated as by 1 XOR x2 plus y1 XOR y2, where XOR is the bitwise XOR operation. The goal is to find the number of pairs I, j such that ij, and the distance between points I and j is equal to k. The solution to this problem can be understood by first simplifying it into a one-dimensional problem. Consider a one-dimensional array and the task of finding pairs I, j in a such that I j equals a given value k. The approach for the one-dimensional problem is to iterate through the array. Count the frequency of each element in A, and for each element I, find its pair such that ik equals a value. You update a counter, raise, by adding the count of the pair's value, and then increment the count for the current element. The solution to the original 2D problem follows a similar approach. You enumerate the XOR values of both the x and y coordinates, transforming the 2D problem into the one-dimensional problem. Then you apply the same process to count the pairs that satisfy the distance requirement. In summary, this solution relies on iterating through the 2D array, calculating XOR values, and finding pairs based on the XOR values to determine the number of pairs with a distance of k. The time complexity is OKN, where n is the number of points in the input array, and the space complexity is ON,